Welcome back to Adventures in DevOps, where we frequently question if a spreadsheet can be a microservice. Today's guest speculated over 20 years ago that the web was being designed suboptimally, where it only took 4 years of maintaining an Oracle ERP system to burn out, found a new company on his speculations, and become successful. The CEO of Ragic, Jeff Kuo, welcome to the show.
Hello, everyone.
Yeah, so I got to say, what was old is new again. You were advocating for the semantic web 20 years ago or so, and now we're basically back to it.
Really? Okay, yeah. Semantic web was the area of study of my master's thesis like 25 years ago. Wow, okay, that's my master's thesis was 25 years ago, and it started out as some studies in AI and semantic web, and it just kind of evolved into this kind of prototype, like creating a system that can be semantically integrated with others, and while being really fast to build. You can build simple database systems really quickly using this kind of technology. So that's kind of the background of that, what also in later years turned into Ragic. So yeah, in my master's thesis defense, I even demoed the prototype, the very earliest version of Ragic there.
Yeah, I mean, it's really interesting because it reminded me a lot about what is being used even in the last decade or so as like JSON LD in like metadata headers within HTML pages. Like, I think it's this real idea where programmatic systems do not want to have to scrape HTML and figure out like what is the important parts of that document. And I feel like it took until a bunch of AI companies were harassing every single website out there for understanding the semantics of what's the point of the company, what does the product do, all the documentation pages for someone to stand up and say, like, we need to do something better.
Yeah, but with the LLM AI coming, it just kind of, in a way, erased the purpose of the semantic web, because agents, they can't understand the semantics and they can aggregate all those. They don't really need the ontology and to categorize them. They can just read it and categorize it in their models. So yeah, that's something we never really expected.
Can we fight on this point? I
Okay,
want to take
sure.
I want to take the opposite perspective. I feel like
Okay.
I've seen in a bunch of the IETF working groups, a bunch of companies that quote unquote are AI companies struggling to parse effectively HTML to actually truly understand. So correct parsing is an issue. I think we end up with a lot of hallucinations because there's no like correct answer that can be extrapolated from that. And the other one is token costs, that companies are trying to reduce as much as they can what they're consuming. And so there's been a desire to shift from human visual language like a UI or GUI to using like LLM's text or something that was basically markdown for processing, because it's more optimized for actually, I hate using the word understanding, but I guess I'll use it here, so that LLMs can understand what the page is actually doing. So I agree that there is a capability to completely parse what's there. There's no reason to necessarily change. I feel like there is quite an opportunity to really go back and challenge everything we've built up and since the .com bust about how we're doing it, and instead go back to those roots that you sort of identified. And really from that perspective, like what should actually be contained in a web page in order to make it usable for the entities that interact with it.
Yeah. Well, I haven't really been in the semantic web field for many years, but I do agree that in detail it's still different from having the correct ontology set with LLM just parsing it. But I do kind of believe that LLM can be immensely helpful in automating this process to generate these graphs. But of course, that will cost a lot of tokens. So yeah, it's kind of like half the answer.
Yeah. So you took this really the goal of the semantic web, which I don't know was entirely realized in the public, and you converted it to, and forgive me for my lack of understanding here, it seems like a much better version of Airtable is what you've built at Ragic.
Yeah, that's kind of the intended effect, and we not really happy about this. We actually started before Airtable, and they got so successful. But anyway, yeah. We are under the same assumption that spreadsheets are kind of the de facto interface that business people like to interact with data.
Yeah.
So in the very beginning, Ragic is nothing about spreadsheets. So in my master's thesis, there's nothing about spreadsheets. We adopted the spreadsheet interface like 2 or 3 years in when we started to really commercialize this product. So the spreadsheet interface was kind of added later to make the whole database building process easier to understand for business people. Because when we're demoing our product, they always say, "Oh, can you do this just like on Excel? Could you like drag this and could you like click that and use hotkey to change focus on different fields?"
Yeah.
Okay, so you're basically asking me to build a spreadsheet interface. So okay, so why don't I just build a spreadsheet interface and everybody could be happy? So yeah, so when we reach the market, we gradually realize that this is kind of what people want, and we're just lucky that underneath it we have the data structure, the flexibility to support something like this.
Yeah, no, I can totally understand that. I think this is one thing that a lot of products get wrong when they are coming up with a new model is they are envisioning what the user experience should be, and users aren't necessarily comfortable or would have to go through the process of learning that. So it's sort of like it's like an unfortunate conclusion that you're like, oh, we have the perfect, user interface that would be beneficial here, but they're stuck on a legacy understanding of how it would work. So in your conversion from going from whatever interface you had to more of a spreadsheet, like did you ever consider having multiple different layers where you could optimize for the particular workflows specifically and let users decide if they want the sort of first level spreadsheet interface or if there's like a more workflow centric view and like let them switch back and forth? Or did you just go all in on like, well, no, spreadsheets, may actually be the right answer?
Yeah, we basically went all in saying that spreadsheet is the answer, because for most database builders, like traditional database builders, you can say Microsoft Access or FileMaker, they usually have a 2-layer architecture. So they have a database underneath it, and you can design the tables, and you could kind of write the SQL, or they generate a SQL for you, and you design the interface pages. So it's usually like 2-layered, and we feel like, and this is kind of unnecessary complication for non-technical people, because for them it's the same thing. So we would like to have them to manipulate the data model and the interface at the same time, because for in their mental model, it's the same thing. So we want to match what they think about the data. So especially in the beginning, it's kind of interesting that technical background people who have written database applications first get a little bit confused when using Ragic. So okay, so where do I create the tables? How do I add the fields? How do I add an index? So it's a little bit confusing for technical people, but for business people, for some people, they just get it like really quickly, and they just don't worry about like changing from one to many relationships. But database people, they'll say, no, you can't do this. That's not right.
It's always that.
But then they're gonna be like, whoa, there's just, how the hell do you do that? Just because it's just structured differently.
I think this is the challenge for technical engineers or even technical business people who like really understand how data works, because that there is like some sort of lie that's been propagated that's unavoidable. And it's like most people don't need to know about that, but they get stuck on like, wait, but how can I do this with my data? Like, are you doing something weird? It's like, yeah, actually, we're doing something weird. I mean, it's clever and weird to deal with the business problem. So you must have had quite the opportunity to learn about those weird oddities that you'd have to put into your product over time, especially building up. Spreadsheet services are not simple. I mean, the UI looks simple, right? That's the sort of lie we tell ourselves, that, oh, the implementation must also be simple. But since you've had such a long go at this, have there been some cornerstone cases or challenging or controversial things that have happened in the last 2 decades or so, good learnings or challenges that you've found with the architecture that you've built up?
Yeah, I think the biggest difference between Ragic and other database builders like traditionally like Microsoft Access or FileMaker is that it's not based on SQL. It's not based on database tables. It's not relational.
Okay.
So it's basically based on graph, like because it came from Semantic Web. I was designing it as a graph, so it has a lot more flexibility. So you don't really need to change the data structure when you go from one to one to one to many, or change it to many. So that's one of the greatest strengths, but it's just really hard to implement. And in the beginning, I was just a master student, graduate student. So it took me quite a long time to get it right. So the first version, in the beginning, I tried to remember this is before spreadsheets. So we're still trying to build this super flexible data model, graph-based data model that can work on any kind of business data. So in the very beginning, I tried to use Hibernate, because at that time it's kind of like the standard. So everything, well, if you have data, you should probably use Hibernate, the ORM to do the mapping and do everything. So I use Hibernate, and I try to implement it with Hibernate, and it doesn't really work because what I'm trying to build is too customized. As you can imagine, if you try to build a flexible database builder, it's not going to be that easy to make all those kind of changes in Hibernate. So I think, okay, I have to write raw SQL. So I changed to HSQL, hypersonic SQL. It was like a tiny database that I can embed in the application. So I began to write it in SQL in a lot of joins. So I began to write really large SQL and try to write code to generate a lot of almost like recursive joins to search through the data. And that kind of worked, and that created a lot of performance problems. So there was kind of a big performance and barrier that we're trying to break. So there's like one day I was just talking to some of my tech friends, and he was talking about how great this thing, the Berkeley DB, how great this DB that a lot of people has never heard of, and he has been saying, oh, how great this is. And I was like, okay, I'll try this out. So then I think, yeah, because I think it solves a lot of my problem when doing these queries on the graph, because at that time there's no tool like Neo4j that a graph database. Yeah, we don't have that. It's quite a few years after my initial development. So I began trying out Berkeley DB, and slowly to see that, oh, this could actually solve our problem. So because what we need is a lot of very, very small, quick queries to the database. We need to quickly query a lot of nodes on the graph and query like what links they have, and if these two nodes have links. So every single one of those queries are very fast, very simple, but we need to do a lot of them. So what we end up doing is that Berkeley DB can be embedded into there's a Java edition, can be embedded into the process. So it's actually, all those queries are just API calls within the same process. So it's super fast.
Yeah.
So after we tried to adopt Berkeley DB, the performance was like 100-fold from the original ones using the SQL. So it made a huge difference. But Berkeley DB is not exactly a full database. It's like half a database. So the problem is that you have to basically implement half the database.
Well, I think today there still are no good graph database options available. And so have you switched off of using the Berkeley DB, or are you still using that to power most of your technology?
We're still using that. Yeah, if it ain't broke, don't fix it. There are still lots of weird stories that we face while using Berkeley DB trying to fix that. There's still lots of problems because, when you're building half a database, there are just tons of unforeseen issues. And I was just a grad student, so what do I know? So I said, oh wow, this works. It's like 10 times, 100 times faster. I'm dedicated to that. So I just feel like this is the greatest thing. This will actually make our product commercially viable. So yeah, so we stick to that, and we've been sticking to Berkeley DB until today. Yeah.
If you had designed the company and the product from the ground up starting today, would you go for that again, or would you consider one of the other, maybe a relational data model or even a key value store for storing the graph nodes in? or an actual first class graph database provider?
Well, Berkeley DB is actually basically a name value store. And honestly, yeah, I would probably still use that.
Cool.
Because yeah, even if I use something like Neo4j, like it's already graph based, but because we write our own indexes, we design our own index, we can do all sorts of cool, weird things with it. So because we have so much low level control of the database, it just gives us a lot more flexibility. But it takes time to work through all those issues and oddities of writing your own writing your own index, writing your own half a database. But we've worked through that, and it turns out pretty well. So we do think it's kind of worth it. Yeah.
It's really amazing. Like for every story that there's, we successfully built basically a database, there's 100 more of that was the worst mistake we ever made as a company, thinking that, we could just spin up a file system, write some blobs to it or blocks to it, and we'd be totally good and not run into problems. It sounds like, in your scenario, given the nuances that are contained in how the product actually works and the specialty and the experience, that this is one of those areas where it was much more valuable to actually gain that knowledge and insight and go from that. And, it's interesting you bring this up for a couple of reasons. The first one is that my company has a product where there is relationships between nodes that we want to capture. And we evaluated all of the graph DB products and all of the relational databases and key value stores and stuff like that to figure out how to store stuff. And we had a very complex model to start out with. And when we were evaluating stuff based off of like P99s of what customers needed or what we even needed to support queries and whatnot, most graph databases would be slower by a factor of magnitude than performing repeated queries or joins on relational or multiple queries to a key value store. If things were simple, you maybe can get away with that one clever query or 3 clever queries or a clever join. And while every engineer who looks at it is like, that's disgusting, I can't believe you would have that in your source code. The reality is graph databases were never designed as like speed optimal things. And so you end up with this huge challenge of, if you want your solution to be fast, you do an ugly thing in your database. And I feel like if you're met with those two options, both it's going to be ugly if you do this with a relational database or a key value store, and it's going to be faster, versus it's going to be slow, but maybe it's slightly better. But we can make it even better if we write our own database.
Yeah.
I'd be really curious to know. You basically have the experience now to potentially go out and just write the whole database from scratch. Have you ever considered making that final leap, like using the Berkeley DB as sort of a starting point and reconfiguring it in a way that would be optimal for the business?
With today's AI assisted coding, I don't think that's that far off. The honest take is that we don't really see a huge need for that. We see a little bit of demand for something that's like inside Berkeley DB that we cannot change. But I do think that for now we still feel it's still kind of a big effort, and yeah, we don't really see the benefit there yet. But maybe someday we will. But really, like a few years ago, when we were tackling with all those problems in Berkeley DB, and yeah, we were thinking about, oh come on, why don't we just write our own database? Because there were some odd bugs, some pretty weirdly serious bugs in especially earlier versions of Berkeley DB.
Please share
Java edition.
Yeah, no, please share anything that comes to mind.
Okay, yeah. One of the most serious one in the earlier version of Berkeley DB is that when the database gets large, like hundreds of gigabytes large, and when it's under like a lot of load, somehow we cannot reproduce this, but we know that it's under high load and a lot of data. It deletes the wrong data file.
No, you don't want to hear this.
Yeah, it deletes the wrong data file, and that is the biggest problem that we face. Like it's for the before the version 4. So right now we're using version 7. So the version 7, we've never seen this on version 7, but on version 4, it just hits us like once every few months, and it just horrible because we have to use like automated backup to restore or try to fix the data. So yeah, we even try to write our own fixer programs trying to fix this, but it's just so difficult because they delete the wrong data, and yeah, it's just helpless when it actually deletes it. So in the end, we came up with a solution, is that on those version 4 databases, they have a flag is to not actually delete data files, just mark it with a suffix, a .del,
Okay.
and you write your own program to delete it. So in the end, we end up using this flag. So Berkeley DB never deletes any data file, and we just periodically scan the whole database and data file folder and move the file with the del suffix into another disk, another larger, cheaper disk, and for a few days, and we make sure that the database is still working all right. And if we find any of those issues, we say, aha, I know this file is missing, so I can go back to that disk and find a missing file. Yeah, and this mechanism has been a lifesaver. It's just a very wacky solution to a bug that we cannot just fix for them. So yeah, that saved us a lot of time.
I think it's ingenious, honestly, as a solution.
Yeah.
And I think anyone who's questioning this has to realize that there is no technology that is 100% reliable, and for databases, 100% durable. You're going to get a failure in some way. And usually it's around the writing to the journal and then, or through the replication process. And then if you have a failover event or a critical failure in your main DB cluster, for if you have like a main writer or write node and the rest of them are readers, like when you fell over there tends to be stuff that is in the journal but isn't written, or isn't even in the journal because it's still in memory and process, and how do you deal with that? And so the fact that you found those, you ran into that issue, and you thought about it consistently of how to solve it in a way which doesn't cause any sort of data corruption. I mean, it's not great that you were forced into it by what seems like a bug in the software.
Yeah, it doesn't only happen at checkpoint. It doesn't happen only on replication, and just randomly, seldomly deletes old some data file just by mistake. It's just very, very painful.
I read all these posts today that for one reason or another that we're not going to get into, decide that going to an on-prem solution is the right thing to do off the cloud. And we can get into this in this episode. But what I want to point out is that they often say, oh yeah, the capitalization or the capital expenditures rather than the OpEx for buying data center resources is cheaper in the long run if you know what you're doing. And I question, do you know what you're doing? Because are you prepared to deal with, it's not just hard drives failing, but neutrinos flying through the air and flipping bits in your non-ECC RAM or on your hard drive for your database cluster. And these things will happen. And you probably aren't designing software with that in mind. Like most people that are doing this haven't been running data centers. Like it's one thing if you're in a cloud provider and you're like, you know what, I'm going to quit. I'm going to start my own company that's its own data center as a service in a particular region. And I have the experiences of building and running that, not just the hardware part, but the interface layer, the software. So I know what to expect. But most companies and most people who work with them, they for sure don't. So what I will ask is, are you running in a cloud, or is all your technology on-prem somewhere?
No, we're running on cloud. Yeah, so even when we're running on cloud, we also have the on-prem version for our customers to use, but it's still kind of, I do feel like the on-prem is kind of the safer, well, the cloud is the safer solution for them, because when they actually see a problem like the system magically deletes a data file, I'm there to help them on the cloud. I went through like 2-3 almost sleepless days to trying to salvage their data, but they don't even have the ability to do that if they wanted to. So it's still nice to have someone to help you out with that. And for infrastructure, we also experienced some pretty incredible failures there. So yeah, on each layer there's just some difficulties. Yeah.
Who wouldn't want the CEO of their vendor being on call to respond to every critical incident that there's a problem that you're waking up an executive to go debug that issue for you. Like that's just another level.
Yeah, but it just I really can't go to sleep knowing that they have data corruption and they can't access their data. It's it's not right.
I know. I totally understand. I can totally commiserate with you. Well, I may not be able to do anything to help. I feel like I have some responsibility to be awake and field support calls or even translate or communicate with that customer with what's actually happening at that moment. Because I know some people that are better at this than me, who've like calm composure, do not panic or anything like that. But honestly, I'm just like, oh God, like we need to have a solution for this when it happens. And it's not a fun time for sure. You mentioned that you're running on the cloud. It's easier to debug, and I'm totally with you because you just have access to a bunch of tools where you can extract data, store it, or even investigate really in a strategic way. Whereas on-prem stuff, you have to be asking, well, are they running it on some weird on-prem cluster? What are they even using for a cluster? How about their hardware or connection, network cables, etc.? Like maybe there's some RJ45 jack that's misbehaving, or power fluctuations that's causing not enough power to be delivered to the hard drive, are just incredible things or challenging to debug. I remember previously in one company I was in, there was an issue in one of the data centers with the Wi-Fi signal, and people would be moving from one area to another one, and that would cause an issue with some of the data, which wasn't being validated correctly because they were using like YAML, and YAML, you don't know when the end of the stream is all the time because it's not encoded. There's no end encoding. So it can be dangerous, if something gets cut off. And there were for sure some issues that are very difficult to debug when they're not in a data center that you can control. So I totally understand the aspect of running on-prem though. There are some customers that absolutely have certain concerns, whether they're security related or usually regulatory reasons for doing that. Are you building the same product basically? Like, are you just shipping them what you're running in the cloud, or are there fundamental differences between these two versions?
They're off the same code trunk, so they're basically the same thing. Yeah, and we try to keep everything with one main version so that it's by configuration. It behaves a little bit differently, but by configuration.
Do you have challenges trying, like, there are some scenarios where you may want to optimize because of the cloud provider. Can I ask you using like AWS or GCP or something specific to Taiwan?
Both.
Okay.
GCP and AWS.
Okay, cool. So, I mean, if
you're
there's
already a story on that too.
Well, we're going to hear that. I feel like there's a thing, if you're just using one cloud provider, there's an opportunity for optimizations utilizing the primitives that are available from that cloud provider. But as soon as you go to two, you start losing that capability. So you're not able to make those same changes. So it's a real trade-off to go multi-cloud. So I guess what I'll ask you is, what went wrong that caused you to have to go down this path?
Okay, yeah. But early in the days in Ragic, we were actually hosted on a service called Linode. I think they're still around.
Yeah.
And it was hosted on Linode. So it was a year, I think it's around 2014. There's if you Google it, there around Christmas time, there was a DDoS attack, a whole series of DDoS attack around Christmas time, 2014. And basically the whole data center went down. So we are not able to have any access to any of our data. So that I was on vacation. So that was just hell. And yeah, I was trying to calm our customers down and trying to tell them, because we still have so little visibility from Linode, because Linode say, oh, we're under very, very, very heavy DDoS attack, so we're doing everything we can, but they cannot give us any visibility. So during that weekend, because it's not like a matter of hours, it's kind of like a couple of days. I think it went down for like almost like 24 hours. And,
oh, wow.
And we just thought that, we really, really can't take this anymore. So because they're kind of remedying on and off. So we kind of start to get about like 30 minutes of time that we can access the database, the servers, and then we get an hour, and then it's down again. So I just decided, that's it. We have to get out of there. We have to move out of there. So we kind of decided and migrated all our services from Linode to GCP over one weekend. So over that weekend. So I was on
Wow.
vacation. So I was not even in the office. So I was kind of like in a museum. I was sitting there with trying to use the museum Wi-Fi, and then my kids were just like off like in visiting in the museum. I was just in the lobby and trying to move everything from Linode to GCP. And gladly, or kind of nice, that we don't have that much data back then. So just like a couple servers that we need to move. So we kind of just moved everything to GCP over one weekend. And later on, we just feels like we need the flexibility to switch services whenever there's we don't want to be buying to one vendor. That's just too dangerous. We want to have the ability to move anywhere. I just told myself we're not going to be buying to one single vendor. And yeah, I know that most people would leverage tools on these like AWS and GCP to scale their services, to automate things. But basically, we just roll out our own service instance management with custom code. We just write custom code, and they can even like SSH to different instances and to do the routine management and to do whatever we want. So we basically just write up our own service management system with connecting by SSH.
I mean, once you've suffered those particular traumas, there's no going back at that point.
That was very, very, very stressful.
That's really early days for GCP too. I didn't even know they were out
Yes.
at that point. And so like that must have been a huge risk even to decide like, okay, not only are we going to go to a cloud provider, but we don't have a lot of options, and they haven't been around that long. Are we ready to even trust them with that regard? But it was enough for you to actually even make that switch. I know, Linode was definitely focused more on the VM side of the house, and definitely a huge challenge to get even more reliability if you want, say, like a database in any particular way, which has backup or reliability set up. Are you using those primitives in the cloud providers though, or are you managing the data? I mean, you're running your own database that isn't offered as a primary option. Like there is no Berkeley DB offered by GCP or AWS today. If they tomorrow stood up and say, hey, we're going to offer a managed version of that, would you switch to that, or would you still run it within the service management mesh that you've created for the that particular provider?
I don't think it's possible with today's technical architecture, because the database runs within the same process. I would think that anything outside of the process would be a lot slower. So we don't even really put database on a different server. They just run on the same process, and they usually use a shared memory pool inside the JVM for multi-tenancy.
Wow.
So yeah, it's kind of different from the other database architectures because we're based on Berkeley DB. There are advantages. There are actually quite a few advantages of using that, because when we're building multi-tenant application with Berkeley DB, and it's actually a very nice tech infrastructure to build multi-tenant applications. They have shared memory pools for all these different database instances, and the database instances are physically separated.
Yeah.
They're not just logically separated. They're physically separated, so that makes it easy to do hot backup and restore. So it's just quite suitable.
Yeah, I suppose the other perspective is that the needs of something that stores data could be fundamentally different from the I/O or HTTP required ports or sockets that are available for a application server. And so combining those needs falls into one of two buckets. The first one is we perfectly match all of the resources available to the VM. Some part of the resources are dedicated to the application, and the other part is dedicated to the database. However, the alternative strategy, and so we have like full utilization. The competing argument is that this the way in which they scale is different. Some queries or requests require more scaling on the database side, or the database resources dedicated for the database. And so separating them is valuable because it's not a one-to-one match. More requests or more complicated requests may not translate to exactly the same thing in the database. Have you found that you're at a sweet spot where the utilization is still incredibly high, or are you sort of wasting some capacity or monetary value by having it on one machine, but making it up with the simplicity of having it all in one place?
I do feel that having it in the same machine kind of improves the utilization because, when you spread it out, it's more likely to have unused resources. So basically, for the application and the database, they're using the same memory in the same JVM. So we can actually configure the percentage of memory to be allocated to the database or to be allocated to the application. That's something we can configure or even change dynamically. So that's a pretty good thing because we can decide how much memory I want to allocate to each database instance when it starts because it's multi-tenant. So we can kind of we look at how large the data set is, and we look at how much usage they have, how many users they have, and we can decide how much memory that we want to allocate to them, and according to the current memory use. So I think it actually gives us a lot of flexibility to move the resources between and the database, what would usually be the database server and the application server. That part is actually pretty nice. So we are able to easily shift the resources between the DB and the AP.
I mean, if you're already in the JVM, have you thought about ever taking the next level and shifting to having your architecture be specifically on like a container native platform instead?
Yeah, they have been deployed on Dockers and containers. Yeah, because sometimes for our on-prem users, they do deploy it on Docker, but for us, because basically the whole installation is like really really simple. And for the application server, we use Jetty, which we embed in there, and for database we use Berkeley DB, which also embedded. So basically, to set up a server, you just install Java and you just run Ragic and be done with it. So it's just not a lot of work not a lot of benefit for Docker, but for some of our on-prem users, they always use Docker, so they can still do that.
One thing that always comes up as a question for me in scenarios where people are basically running all of the infrastructure themselves on a virtual machine or even bare metal is, how do you scale testing effectively? Because from my standpoint, it's always been, if you have containers, it's easier to deploy them, make some configuration changes, understand memory utilization, CPU utilization, et cetera, and actually watch where they fail, potentially if you're doing some sort of load test. Do you have different deployment modes to be able to capture that well, or have you found particular sweet spots in how you actually do load testing in the model that you're running today?
I don't think there's a lot of special thing that we're doing with these load testing. Yeah, we just have some test instances and test servers on GCP and AWS, and also we also have some local machines in our office that we can use to do these load testing. So yeah, they're just some. We don't really scale those tests. So yeah, we just do some because they're basically a monolith. So it's kind of easier to just test that.
Yeah. No, I totally get it. One thing you did mention, you hinted at a little bit, was your multi-tenancy model. And so I am curious about your product, especially if you have on-prem or customers that are deploying it themselves. And once you have that, and if you have the same basically source running for those models, as well as in your own, say, cloud environment, then rather than a multi-tenancy model, I found a lot of companies just deploy a different set of instances for every single customer. Are you doing that, or did you mean something different you're doing something different than that?
Yeah. For one instance, we are running like thousands of tenants on each instance. So that's one of the good thing that I talked about, that they can use a shared memory pool on Berkeley DB and say we're running thousands of thousands of customers on the same server, and that's of course that's still kind of a technical challenge that has caused some problems, because like the biggest problem would be like the noisy neighbor problems. Is that
For sure.
some accounts, they are taking up a lot of resources, or then the others affecting the service quality of other accounts. So there, we've learned from experience and added a lot of those quotas and limits to everything that might take up extra resources and might starve other neighbor accounts, neighbor databases. And another thing that we do a lot more and more based on these is that we try to do most of the processing using an asynchronous queue, like a blocking queue, so that when certain account is trying to execute 100 or 1,000 things at the same time, we just try to put that in the queue, so that it's not going to hog up all the CPU cores. It's not going to hog up all the memory. So we will, on these kind of multi-tenant environments, we have to, for everything that might take too much resource, you probably has to put it in a synchronous queue, so that it's not going to all fire at the same time. So
I'm guessing you didn't start out that way.
I didn't.
I'm guessing
didn't start that way.
Yeah, you didn't start that way. What was the straw that broke the camel's back, so to say?
Oh, I can't. Wow, to say I can't even remember. But that back broke long ago, because you hit that problem pretty early on. Especially in Ragic's model, is that people can build anything on Ragic, any type of database application. So we see all sorts of weird use of Ragic pretty early on. So in the beginning, we hit that problem quite long ago, and yeah, so I started kind of writing my own blocking queue to try to fix this. And we had our first blocking queue for this purpose quite early on, but of course a lot of things didn't live on the queue in the beginning, and then we see people starting to misuse it or accidentally use too much resource. It was just, we need to use the blocking queue for this too. So yeah, we just slowly begin to move almost everything that takes resources to the queue.
I mean, it makes sense. It's certainly one of the things early on when we were designing our solution, we knew that this was going to be a problem in some regard, and you have to come to the floor, basically, come to the table already believing that there's something that you're like. You have to have the tools in front of you in order to be able to do something about it. You don't necessarily need to implement it at the beginning, or you need to have a database that exposes hooks that allows you to build your own technology on top of it to relieve back pressure. Or prevent abusing the database or resources that are available. There's actually a whole episode where we went into some of the differences between single tenant architecture and multi-tenant architecture. So that episode will be in the link in the description. So maybe we won't focus too much on that for now. But one of the questions that I sort of want to get into is, I think in the last few years, we see a lot of people standing up and saying, oh, I rebuilt MS Excel in one weekend and it's great. Or I rebuilt Airtable in one weekend. And me personally, I'm rebuilding Gmail as a product right now. And I can tell you, it's taking a lot more than one weekend. How is the current ecosystem and the product climate fundamentally impacting your organization, or the technical challenge you're seeing today versus the ones that you would have seen in, say, the last 15 years prior?
Yeah, what you're saying, those I built something in a weekend, because I was really curious about that. So let me address that. In like a few months ago, so I was like, wow, so really no coding experience, you can build that over a weekend. So I have two kids. They're 12 and 14. So they always ask me to help to teach them coding. So okay, so now we have those LLMs. So I'm gonna teach you how to not code, and let's build a game. We went up on a small project to build an RPG game, sort of like a Dragon Quest. So I decided I'm not going to do any coding. I'm not going to even look at the code. So we begin trying to create an RPG game. In half an hour, there's a working RPG game that we can play around. It's just amazing. And I was like, this is why people say, I built this over the weekend. I built this over just over like 3 hours. So that's kind of a magical feeling. But the next day and the next week, because the code gets bigger and bigger, and just there's just a lot of problems that begins to arise because it just takes longer and longer for AI to kind of fix a problem, and it often says that it fixed a problem, and it doesn't really fix the problem. So I begin to look into the code, and it's just really bad spaghetti code, and with some really bad designs. And in the beginning, because I never told him what kind of design we want. I just have my kids tell me, I want this, I want that. So the design is like really bad. But the amazing thing is the game still runs.
So I want to ask, because I feel like that is often the response in these areas. And the feedback that I get in those moments are, well, Warren, it's a skill issue. If you were better at prompting the LLM, then you wouldn't have spaghetti code in the first place. And yeah. I don't agree. I have tried so hard to make it so the code can be maintainable at a long period of time, and I haven't found that to be the case. And I'm sure with your experience that you weren't. I mean, I'm not looking at it, but on the same time, I was like, I tried to get it to fix it, right?
So this is a fun side project I do with my kids, but at work, I find the LLM never been able to do the system design correctly. It's probably because our product is kind of different. Because if you're building like an e-commerce site or like ERP system, I would tend to believe that they can build something pretty standard and pretty much right. But I don't think that it has enough background understanding on how to build something that I want in the database builder. So it knows the concept, but the design will be really bad. So every day when I'm working, I still work with LLM to help with all those design all the time, but just that I always have to tell them, oh, this is wrong because of this and this, that, so you have to change that. And I don't know, I still work with them, although I end up with coming up with all the designs myself. But, talking to them helps me organize the thoughts, I guess. And they can write up all these documentation about our design plans really quickly. So that's also a plus. But in the end, I would look at the design. They're still made by me. Their design is usually pretty off.
Yeah, no, that's sort of what I've experienced. And I've been trying to figure out if different tools or different harnesses change the approach here. But I think the fallacy is sort of the same one that you've run into, which is in my area, whatever my area is in quotes, it can't be used. But if you look at other areas, it's no problem for it to be used there. And I think that's where like there's a devil in the details, where like if you actually go and try to implement an ERP system, I will tell you, I will tell you how complicated it is and how much the LLM will get it wrong. And I think that's sort of
okay.
Yeah. But I think this is the thing where the area where we're an expert in feels like it can't work or does not work very well without a lot of micromanagement. And when we push it to other areas that are outside of our expertise, it feels like it does a much better job. But when you ask experts from those areas, they give you the opposite feedback. Oh, building a spreadsheet tool, I can do that with an LLM. Matter of fact, I just saw 10 products on a product hunt yesterday that were all, selling the Airtable replacement. So, that's an interesting perspective. But with that, maybe this would be a good moment before going further down a tangent to switch over to picks for the episode. So Jeff, what did you bring for the audience today?
Okay, yeah, it's one of I saw on your intro you could be one of the adventures, and actually in about two weeks I'm going on the backpacking trekking trip to the mountains in Taiwan. It's called one of the mountains is called the Nanhu Mountain. So yeah, and Taiwan is where I live or where I'm from. And Taiwan is like a kind of a small island, but it has a lot of mountains. So like 60% of Taiwan is mountainous areas. And I've been to like the Rockies, I've been to Alaska, Switzerland to see the Alpines. And the mountains in Taiwan are just very different. The sceneries are very different, but equally beautiful. And I'm just really excited about the backpacking trip that I'm embarking on in a couple of weeks with my college friends. And I would just love to bring up that, if you love hiking, if you love trekking, backpacking, and you love mountaineering. Taiwan is actually a really, really nice place to visit because there are just a lot of amazing sceneries in the mountain areas.
Is there one particular peak or trail that you would recommend above all the other ones?
One of the most popular area is the Taruko, the Taruko National Park. So it's sort of like the Yosemite, but in a different flavor. So you can kind of expect kind of the same valleys, but in the Taiwanese flavor. So it's a really, really nice place. There are a lot of hiking trails there that you can take. So it's a very, very nice place. There are a lot of mountains you can climb there.
Wow, it's like compared it to my two favorite places, Switzerland and Yosemite National Park. That's a hard sell there. I'm gonna maybe now have to take the transit out there to see the mountain range, which is just really interesting because I just finished the Jet Lag the Game season where they're in Taiwan going around, and it's interesting because they're only going around the edge of the map on the rail, and you can't get through the center of the country because it's just a whole mountain range, which is quite inspired.
Yeah, it's just really beautiful.
Okay.
I just love it.
Well then, I love the pick. For me, maybe mine's a little bit less inspired. I'm going to pick the DevOps Days conferences. So I just got back from the one in Zurich, and honestly, they're the best conferences I've been to anywhere. They're non-commercial. They're run by volunteers. They're very well done. People very committed to it. And just I've been to ones in a lot of different European countries. And honestly, if you can go, you absolutely should. And more importantly, if you can sponsor one of them, I also highly recommend it because really, out of all the conferences, they don't just focus on technical aspects. They find opportunities for cultural improvement and having a higher level of conversations than you normally get at just like a Java or C# or JavaScript conference. And way better than what you get at like an AI conference where you're just discussing the best new skills to throw into all of your agents.
Oh,
I don't know if you have.
Cool.
Yeah, I don't know if there is one in Taiwan though, but maybe I'll look it up after this call and see if they're offering one. Basically, it's up to volunteers to start and run it. There's a global organization, but it's all volunteer based, and it's one of the few conferences that I go not just as a speaker, but I actually pay to attend. And I don't know what it is. I don't know if it's about the branding or the mentality or the culture of the global organization, but individually they always seem like they're way more in tune with what people actually want and what should go on. And they're very careful about who can sponsor and what sort of talks can show up.
Okay. Yeah. Should search if there's one in Taiwan.
Yeah.
Yeah.
Well, thank you, Jeff, for being the guest in today's episode. I didn't know where we were going initially, but I absolutely love talking about all the technical things that a executive can still get down and do. So thank you so much for coming on for the episode.
Thank you, Warren. It's a pleasure talking to you.
Well, it's been great. And thanks to the audience for tuning in for this week's Adventures in DevOps. And hopefully we'll see everyone back again next week.